Thanks, Ashita, for the introduction. Hello, all, and good afternoon. In this session, we'll be discussing about the system design and specifically high-level design in detail. Let me share my screen. Just give me a second. So, in this session, we'll be discussing about the system design and specifically high-level design in detail. Let's go to the session. So, here's the high-level agenda for the session. We'll start with the definition of system design. Why is it even needed? Common design principles followed in the tech industry, the types of system design components, and the detailed view of high level design. And also, we'll be covering where does the HLD, the high level design, come into picture in the real world software development lifecycle. And in the end, we'll be quickly covering a software design problem for Netflix. Okay. So, yeah, let's start. What is system design? So it is a process of designing the modules, components, interactions between them, complete architecture, their interfaces, and the data management of a system. This is about a theoretical definition. Now let's compare this with an analogy. So if you want to construct a building or a home or any kind of building, right? What will we do? So before starting the construction, the engineer will prepare a plan. This plan will and it should contain literally all the details about the building which is going to be constructed. Okay, so let's consider some major aspects that should be included in this plan. First of all, what is the purpose of this building? Let's say the plan will be entirely different for a hospital, which is an office, or it's a simple residential apartment. Okay, next factor should to be considered is like scale of the building. Let's say how many floors should the building have, and what is the number of rooms in each floor. So this aspect will determine the overall users who are going to be benefited from this building at any given point of time. Okay, and next important factor may be entry and exit plan of the building. This may include emergency exit plan as well. And another important aspect of the building can be durability. So what are all the possible obstacles that can be encountered by the building and how will it overcome from them? For example, we can consider some basic and common natural calamities like heavy rain or storm, or how will the building will face these kind of obstacles. So similarly in the software world, right? So we can consider that what is the purpose of this application. So whether it will serve some social media like Facebook or a streaming application like Netflix or Prime Video, and scale of the application. So how many number of users will be able to serve? Let's say if you consider the Facebook, right, it will be having billions of accounts, right? And if you consider some gaming platform, multiple number of players will be using a in same game at the same point of time, right? So, and how do you design such a scalable application? And yeah, so let's move to the next part. So these are all the elements involved in the design system. Okay, so this will be like the blueprint of the entire system. It characterizes the construction, behavior, and individual views of the system. Okay, now next is modules. A module may comprise of a single or group of components used to achieve a particular goal in the system. To give an example, let's consider an application like Facebook. We can think of the login page, right, which handles the authentication and authorization part as a single module. Coming to the components, this refers to the actual building block of the system. Typically, this consists of an independent block of code which accomplishes a minor task. Okay. Next, interfaces. So this handles the interactions between the individual components and how will they communicate with each other, the communication order also, if it is applicable to that specific application. Okay, now let's talk about data. So this is one of the most important part in the system design, and some of the major aspects in this specific to data include what are all the data that is needed by an application, and what are all the data that is not needed by the application after some specific point of time, how to store them efficiently, and how do you ensure privacy and security over the data, and yeah, etc. So these aspects will be covered in this data element. Now let's talk about why the system design is even needed. So technically, to give adequate itemized information and data about the system and its components to empower the execution to steady with the building substances as characterized in models and perspectives on the system architecture. So practically, constructing a system needs lots of resources. So to ensure that the resources are utilized optimally, there should be a plan. So that plan is what we call system design. So this can be in both physical real world examples, right? Like we talked about constructing a building, right? Let's say if we start to construct a building without even a plan, so can you even imagine such a scenario? So practically it will lead to a lot of wastage of resources, right? So without even plan, how can you even construct a system? So construct a building. So the same rule will apply for any kind of software application as well. Next, let's talk about the principles involved in the system design. Okay. So yeah, the primary principle will be scalability, as we have already mentioned, right? So how many users or customers will be benefited by a particular application? And again, the scale can be global level like Facebook, or a country level like IRCTC, which is used to book train tickets in India, right? So if you have used, let's say, even specifically, right, how does the traffic will be handled during the Tatkal booking time? So it is a time where almost more, I mean, all of the users will try to log in and book tickets for a single train or maybe limited seats, right? So how do the customers will try to book the tickets? And let's say we have around 100 seats in a train, right? There may be more than thousands of people will be competing for that particular 100 seats. So how does the system handle that particular scale? Okay. And let's say even if Amazon or Hotstar releases some primary, I mean major movies in their video streaming platform, right? So there may be a huge number of traffic that will be coming at that particular point of time. And or even Flipkart or Amazon open some prime day sales or special day sales, right? So at that particular point of time, there will be tons of users or tons of requests that will be coming to the system. And how does the system handle that? So there shouldn't be any bad experiences to the users, right? So how does the system ensure that all these factors should be accounted while designing the system itself? So this particular scalability is planned for that. Next, let's talk about reliability. So this handles how the system will be performing the expected tasks without any problem and without any mistakes. Okay, so and again, let's talk about the IRCTC, the train ticket booking app, right? So the user is logged in and he is trying to book a train ticket. After deducting the money, right, the system should be able to book the intended ticket. So that is the major functionality of the system, right, which is intended to deliver. Okay. And what if the system fails to do that? I mean, after detecting the money, right, either the ticket should be booked, or if there is some failure, right, it should be able to refund the money back to the same account. So this is the success and failure scenario. There shouldn't be any other scenarios like this. I mean, after detecting the money, nothing happened. So how does the user feel, and how does the system will handle such situations, right? So those kind of aspects are come into this reliability part. Next, let's talk about the availability. And if you have used this IRCTC, right, we have some downtime. Maybe the system is not available to particular period in a day. Let's say it's around night 10 p.m. to 11 p.m. So for a system like IRCTC, and planned downtime is perfectly fine. And what if the system is not able to serve the request during the peak time or its intended serving time? And let's say even in Amazon or even some Netflix video streaming platform, right? So you are watching some movie, and or you are shopping some things in their e-commerce websites, right? So it shouldn't go to suddenly unavailable state, right? So it will definitely impact the user's performance, and it spoil their system's reputation itself, right? So we should be accountable for this availability aspect as well. Next, let's talk about efficiency. So the system should be able to perform given tasks quickly, consuming the resources in an efficient manner. Okay. And again, if you consider applications like IRCTC, right? Earlier, it used to be very slow. If, after a single click, right, the system will be taking too much of time to respond to some maybe single events, right? Let's say if what happens if you face some similar efficiency issues with while watching some movie, will you even be able to watch some movies with that much of bad experience? Definitely no, right? The user will not be able to adjust that experience. So efficiency plays a major role in system design, especially for the low latency applications. Okay. And next important aspect is maintainability. So if it is easy to make a system function smoothly and understandable for beginners or whoever looking at the code, right, it should be easy to understand from the developer's point of view. To give an example, right, Microsoft Word has 20 million lines of code. Think about such enormous lines of code, right? It's not organized at all. Do you even think people can read the code? Or let's say you need to add some minor features in the system or in the application, right? If the system is not designed properly or it is not structured properly, it's not, if the data on the and the code is not organized properly, right, the code is almost waste. I mean, you cannot even add anything or modify anything or fix a bug and anything, right? And similarly, there is no one in Microsoft who knows the Microsoft Excel end to end. It has tons of functionalities, and no single person can tell about what will this MS Excel is capable of. But it should be organized so that it's easy for it's easy to understand for all the developers or the other persons who are reading the code, right? So the system eventually should be maintainable. And next, user experience. Okay, so and like we discussed earlier, if the in IRCTC or Facebook or even the video streaming applications like Prime and Netflix, right? So user experience is the final thing which directly interacts with the user, right? Let's say you have efficiently designed the backend of the system, and the video streaming is smooth and it is perfectly scalable, reliable, available, and everything. But the user experience is not good. Let's say it's not responding to some button click, right? Or specifically in the user facing component, right, the component is not designed well, the user experience will still be bad, right? So even that should be accounted while designing the system. Okay, now let's talk about types of system design components. So high level, we can classify this as high level design and low level design. So high level design refers as the generic system design. So once we finalize the software requirements, right, the first thing which we design is the high level component design. So this will comprise of the application's overall description, architecture, what database we are going to use, the summary of the system components, the internal microservices, what are all the platforms or the frameworks which we are going to select, and everything. So after this phase, we'll be getting the finalized database design, functional design, and if it is ready to be designed in for low level components. Okay, so next, the term low level design refers to the complete description of all modules. Let's say from the high level design, right, you have decided to use this framework, I mean a particular framework for the application, this kind of database for the application, and you have opted to use some content delivery network in the application. You have also chose to use some kind of cache inside the server. Okay, so this is the outcome of the high level design. So once you get the overall blueprint and the high level design, right, the next is to design each and every individual module and component. For example, inside the let's say you, for the application server, you have selected some framework. You will be designing that particular framework's functionalities. What are all the responsibilities of that particular component? What are all the responsibility for that particular database component? Let's say if you have chosen to use SQL databases, right, and what are all the tables involved in it, what are all the schema for particular table, and for the caches, right, if you are opted to choose Redis, and what are all the key value pairs which you are going to need in the system development, or even using the system, right? So this kind of component level design refers to the low level design. So after this low level design part, right, you will have the program specification end to end. Okay, so this is about the low level design part. And yeah, now let's look at where does this high level design come in the entire software development life cycle. So here you have the first phase is requirements gathering and project setup initiation. So right after the requirements is finalized, right, the you need to design the software. So as we can see in this life cycle, right, design comes way beginning in the software development life cycle. So once the design is finalized, you will be able to develop the code which the design states. And once it is developed, you will be proceeding with the testing and the actual production deployment and the support. Okay, so now let's look at the high level design for Netflix. So Netflix, if you haven't heard about, it's about the video streaming application, and there are primarily three major components. One is the client. Client is about, let's say, the video streaming platform supports any kind of clients, be it a TV or a laptop or even mobile, right? So it should support what about, I mean, all the, maybe it should support all the relevant clients that can be used to access this Netflix. The second major component is the Open Connect. So it is the CDN, the content delivery network platform, which Netflix uses internally. So Open Connect is a program to provide the millions of Netflix subscribers with high quality viewing experience possible. So internally, this Open Connect has partnerships with the ISPs, the internet service providers, to deliver the content more efficiently. So we'll talk about this later in a while. And the third major component is the database. So this is where the actual video data, the tons of video data, will be stored in this database. So let's look at how this data is organized and how they are delivering this video content to the clients. Okay, so let's start from the client. Okay, so let's consider this scenario. I'm starting to stream a movie from my laptop. Okay, and I passed at some point, and I may need to view the same movie at the same point where I left in another device is also possible. Now, if you consider a practical scenario, right? Let's say the laptop is of some highest resolution, let's say 2K, and my phone is, let's say, maybe 720p. Okay, so how the data is organized in the backend? If you think about that, this transcoder is the part which is responsible for encoding and decoding the content and delivering to the client which is appropriate. If I'm streaming the movie from mobile, right, I'll be able to get the relevant data which is apt for my client. If I'm streaming the same movie from different device, right, it should be able to deliver the relevant content. So if I see a lower quality video in my laptop, it will be definitely leading to the poor user experience, right? So yeah, those are all the design decisions which we need to take when we consider the client part. Next, there are server components, which, let's say, here they are using Netty servers, which is a non-blocking IO and event driven servers, and they have a lot of filters to identify the kinds of requests, and they have a lot of microservices internally before getting into the database. So let's say they are using one more cache component. So this is the distributed in-memory caching solution based on Memcached. So without getting into much details, right, let's say uh, the data is huge. You are watching around 5 GB of movie, assume that. So you are in X minute, you will be able to see the next seconds or next minutes video flawless, right? So for that, definitely they'll be using internal cache, and in the client side, right, from the cache, they'll be fetching the content with some buffer. So for these kind of scenarios, right, they'll be using the caching mechanisms and designing this particular cache and where and when to use the cache. All these decisions are made from the design phase itself. in the high level design. Okay. And next, they have some MapReduce platform which manage the Hadoop framework to handle big data. As I already told, they handle lot of, petabytes of data, and probably even more than that. They'll be handling this data using this particular component, the MapReduce, and which internally use the Hadoop file system. Okay. And next, they have multiple message queuing solutions. One of the major thing is Apache Kafka. So this is an open source distributed event streaming platform. And actually, this Kafka is not only used by Netflix, they are used by other companies also, where they need to build real-time streaming data pipelines and real-time streaming applications. So this is how it is used. And coming to the database part, right? So majorly they use Cassandra, which is again a free and open source distributed wide column store database, and it is a non-relational database. So it is all about choosing which component and which exact framework to use to solve for that particular component. Okay, and all these considerations are taken in the system design phase of the Netflix application itself. And so I'll try to answer few questions. Okay, so few people are asking me about the Kafka and Cassandra part, right? So Kafka is a distributed event streaming platform. Okay, so you can consider this as some message queuing systems, right? Let's say the video is continuously streamed through some pipeline, right? So this pipeline is what Kafka means. So actually it will be able to support any real-time streaming data. It's not necessarily need to be some video streaming, maybe at whatever kind of events it will be able to support. And regarding the Cassandra part, right? So if you heard about the NoSQL databases, which is non-relational, and there are multiple categories of NoSQL databases, and one such category is the column store. So let's say for particular key, right, the data can be of multiple columns. Let's say for key A, there can be one value can be 5 column, and for some other keys, right, the number of columns can be variable in the wide column store. This Cassandra is one kind of such wide column store database. So if there are no more questions, let's wrap the session, and thank you everyone for joining.